video, we are going to explain about the project that is a security and privacy preserving consortium blockchain based accessing control in mobile crowd sensing. So before getting into the execution, first let us understand what is the project about. Mobile crowd sensing. It is basically when everyday people use their mobile phones to collect and share the data. This could be information about traffic, locations, or even city planning. On one side, organizations or stakeholders they create tasks, and on another side, mobile users complete those tasks by uploading the data to the cloud. It's a smart way to gather large amount of information and improve the quality of services. However, this process also comes with the challenges. Since so much personal and sensitive data is being shared, there are serious concerns about privacy, security, and whether users can fully trust the system or not. Ensuring that data remains safe and that people feel confident while contributing is one of the biggest issues in mobile crowd sensing. So one of the big issue with mobile crowd sensing is that when people take part in different tasks, there is risk that stakeholders might get too much access to their personal profiles and the data. This could cause privacy leaks. On top of that, attackers can create fake or malicious apps that trick users into sharing their data, which can then be stolen and misused. And another big issue is that with the centralized systems that are commonly used for this problem, they often have weak access control, meaning they can't properly decide who should access what data. They also lack fine grained authorization and they are vulnerable to hacking or data manipulation. Plus, if the same data is searched again and again, it leads to the extra computation and communication costs, making the system slow and inefficient. All these issues show why we need a secure, privacy preserving, and an efficient access control system for mobile crowd sensing. So, to overcome from all such issues, the system we are proposing uses a consortium blockchain based access control or CBAC to tackle the privacy and security issues in mobile crowd sensing. It ensures that all the data collected and shared through mobile devices is properly managed and protected from unauthorized access. So as this project is prototype, this project only uses a single blockchain enabled server that handles all the operations, including registering users, creating tasks, uploading the sense data, and controlling who can access it. By using blockchain, the system keeps the data secure, transparent, and traceable so both stakeholders and mobile users can trust the process. So in the system, stakeholders first register themselves and create sensing tasks by entering keywords related to the data they want to collect. Mobile devices, once registered, can see these tasks, choose which one to participate in, and upload the data they collect. To make sure that data stays private, all uploaded data is encrypted using AES algorithm before it reaches the server. And here on top of that, the system uses searchable encryption model for the task keywords. This means stakeholders can search for and access the relevant sense data securely without exposing the keywords to anyone else. The blockchain keeps a record of everything, including user details, tasks, encrypted data, and encrypted keywords, so that all information is secured, cannot be altered, that is, cannot be altered, and can be traced whenever needed. Moving on, access to the sense data is carefully controlled so that only authorized stakeholders can see it. When stakeholders want to retrieve the data for a particular task, they have to provide the correct keywords related to the task. So these keywords are encrypted and then compared with the encrypted task keywords stored on the blockchain. Access is granted only if there is a match. This method ensures that data is only shared with the right people and keeps the privacy of both the stakeholder and also mobile device protected. And moving on to the Ganache part. So in this project, we have incorporated Ganache. So this Ganache, it acts like a personal Ethereum blockchain. Here we have multiple blockchain environments, but we are using Ethereum blockchain. So this Ganache acts like a personal Ethereum blockchain on the computer that we can use to deploy and test the smart contracts. It gives accounts to stakeholders and mobile devices and keeps track of everything that happens, such as when tasks are created, data is uploaded, or access is verified. It also shows the details of each transaction and block, including gas used, which helps to make sure everything runs securely and transparently. And coming to this MetaMask part, so this MetaMask, it's a browser-based Ethereum wallet that connects the users to the blockchain. It allows stakeholders and mobile devices to perform transactions safely, like creating tasks or retrieving the data. MetaMask also shows ETH used and gas fees for each transaction. So users, they can see and trust that everything is being handled correctly. And to make the system faster and more efficient, here as an extension, cache memory is added to store the results of the previous search queries. This way, whenever a stakeholder searches for sensed data, the system first looks into the cache. If the search result is already there, fetched, it is fetched directly without performing a new search on the blockchain. This reduced repeated work saves the communication cost and also significantly cuts down the time needed to get the data, making the system quicker and more efficient. So this is the project. And now moving on to the requirements. To implement this project, we need hardware and software requirements. In hardware, we need processor of 5 and above, RAM of 8 GB, and ROM of 25 GB and above. And software requirements are Python, ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, MetaMask as a Chrome extension. And backend languages are Python, JavaScript, Solidity, and framework used as Flask. And frontend languages are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, let's open the code folder that contains source code files. So these are the source code files in the code folder of the project. So in the build folder, we have JSON files, and in this folder, we have Solidity code, and this is the migrations folder, and this is the static folder in which we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual and interactive aspects of the application. And this is the templates folder. This folder consists of HTML pages used throughout the project. So it includes pages like index.html, about.html, home.html, representing various sections of the website. And this is the app.py file. So this .py file contains the information related to front-end logic. And this is the Windows batch file. Instead of executing project through command line interface, we have created this Windows batch file. So before running this project, we need to host the blockchain server. So let's open Ganache for that. So now select the workspace. So application has been hosted. Blockchain has been hosted. Here, if you observe, initially we just have 4 blocks. So minimize it. Now run the server file. Click on run. Here, if you observe, we can see app.py file has been compiled. Now application will host at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. So copy this local link provided by the Flask framework and paste it into any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. So paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now, before doing any action, that is before registering or before logging in as stakeholder, uploading some task or like that, let's see how much of the balance we have in our MetaMask wallet. So let's open the MetaMask. Here, if you observe, I have 99.98 ETH in my MetaMask wallet, which represents the amount. So in the context of blockchain, transaction refers to the action. So after now, we do transactions, right? When we do transactions, gradually this amount will be decreased. Here, transactions refers to the actions or operations that are recorded on the blockchain ledger. So let's get back. Now let's start doing. So first, let's get registered. Click on register. So let's register as stakeholder. So let's give as stake 1, or else let's give any other name. Ramesh underscore S, because he's a stakeholder. Let's give him password and give his number. And as his stakeholder, let's select as stakeholder. Now click on create account. And now let's register as mobile user. So for that name would be Suresh underscore M. And let's give password here and then mobile number. So I'm giving a random mobile numbers here. Select mobile device and click on create account. So here if you observe, accounts are created successfully. Now first we need to get login as stakeholder. Click on stakeholder login and give your username. So username is Ramesh S that we have created recently and password. Give the password here. Now click on login. So we have successfully logged in as stakeholders. So now here, if you observe, we have multiple buttons that is generate task, view task, download mobile sense data, and blockchain's computational graph and extension cache graph. So first, stakeholder supposed to create the task so that mobile user will be uploading the data. So let's click on create new task. So let's describe something. So stakeholder, or else let's create as Ramesh new task. Or else let's just give it as new task, which would be simple. And now click on generate task. So task has been generated. Now click on view task to see whether it is generated or not. Here, if you observe, Ramesh S, who's a stakeholder, has created task and that description is new task. And this is the time, this is the date when that task has been created. Now let's log out and log in as mobile crowd sensing user. So before that, let's go to blockchain that is Ganesh and see how many blocks are created. So click on blocks. Here, if you observe, initially we had only 4 blocks. Now we have 5, 6, 7, 8, 9, 10 blocks. So when we have created user Ramesh, this block was generated. And when we have created user Suresh, this block was created. Accordingly, whenever we did any particular transaction, for that block has been created. And for every block, we will be having date and time when that block was created. So let's click on block 7 for now. So block 7 is for creating new tasks. Here we have block hash, gas used, gas limit, and transaction hash. So if you click on this transaction hash, we have gas use, gas price, gas limit, mined in block 11, and this is the transaction data. Now minimize it. And now let's log in as mobile device login. So give the username and the password. So it would be Suresh underscore M, who's a mobile user, and give his password. Click on login. So the user also has logged in successfully, that is mobile user. Now he need to click on upload data. Click on it again. So here he is to choose the task. He is supposed to choose the task. Click on new task. We have only one new task that is has been created by the Ramesh who's a stakeholder. So select that and he can upload any file. So click on choose file and you can select any of the file you want and click on open. It has been loaded and now click on upload data. So the data has been uploaded successfully. Here you can observe data has been uploaded successfully and that data, it will be stored in the server in an encrypted format. That is by using AES encryption technique. Here if you observe in the blockchain, that is in the Ganache, a block number 12 has been created in which the data has been stored. That is the uploaded TXT data has been stored. Now minimize it, log out. Now log in as stakeholder to download that data. Give the username, give his password. Now click on login. So we have logged in successfully and now click on download mobile sense data so that he can see who all the mobile users has uploaded the data. So our search query is new task because this is the description that we gave, new task. So here we will be using searchable encryption technique. This uses to search the keyword that we have given, and if the given keyword and the task description, if it matches, then it will give the data. Then it will be giving the mobile data that has been given by the mobile user. Now click on search data. It is in searching process. Here we got the result. So Suresh is a mobile device user, and here we have task related details that we have searched for, and here we have file name which is uploaded by the mobile device user Suresh. And now the stakeholder Ramesh will be able to download that file. Click on download, and here if you observe, requirements file has been downloaded. So in this way, if we search for another query, let's just normally type ABC and click on search data. Click on search data. So here you can observe no data found. Here, searchable encryption technique, it is searching for the word ABC. As there are no tasks with the ABC, match has been not found. That is why it is giving the result that there is no data found. Close it. Now click on block computation graph. So here, this is the block computation graph, which is a visual representation of the blockchain's computation data and performance metrics. Here on x-axis, we have block number, and on y-axis, we have computation time. Now let's check with the extension cache graph. Here on x-axis, we have number of requests, and on y-axis, we have overhead time. So now click on logout. We have done so many transactions. Now let's see how much balance we have in the MetaMask. So here I have 99.98271 ETH in my MetaMask wallet. So this ETH balance, it remains unchanged after each block creation because the project's action don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance changes. Now let's see how many blocks have been created. So total 12 blocks are created. In this way, by using blockchain, stakeholders and mobile device users can securely use the system for doing tasks, for generating tasks as well as for uploading the data. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.